Unlike animals, certain people have a tendency to drink excessive amounts of alcohol and to go largely beyond the stage of feeling good. For the most part, animals do not adopt this type of behavior.
Their natural instinct is to stop consuming alcohol just before they become drunk, and they do not often reach the same state of inebriation as humans.
When considering animal alcohol consumption, we should disregard accidental ingestion that occurs with domestic animals when the taste of alcohol is masked by the taste of the beverage. Well-known vet Yves Layani and his parrot Coco celebrate Shabbat every Friday night with a small glass of port. After just a few sips, the parrot starts whistling. Be careful if you're not a veterinarian. The slightest overdose can be fatal. For humans as well as animals, excessive consumption is dangerous. Every day, the loss of vigilance, reaction time, and motor coordination is responsible for thousands of accidents worldwide. Alcohol and drunk driving is responsible for 1/4 of all recorded road accidents that result in fatalities. Alcohol is also responsible for certain psychological problems. Advanced drunkenness is often accompanied by a marked increase in aggressive behavior and is the source of many incidents or accidents at home and in social or professional environments. It is easy to imagine why animals don't drink themselves into a state of inebriation. Birds would not be able to fly and monkeys would fall from their branches.
In a natural ecosystem, it doesn't make sense that they move drunken around in their home ranges. So that would be heavily selected against, because it would just increase the risk for falling prey to another species.
A population of drunken animals would soon become extinct. But for humans, the harmful effects of alcohol do not prevent excessive casual consumption. The ethanol molecule has a dangerous consequence: addiction.
Addictions are a very big problem today, and alcoholism is the most dangerous and damaging of all the addictions.
As with nicotine, cocaine, or heroin, alcohol has the capacity to engulf its consumers and to deprive them of their freedom of choice. Alcoholism is a worldwide problem.
They can't stop, and they destroy their lives and their families and everything.
Alcoholism affects 140 million people around the world. The consequences are horrendous. Alcoholism is the source of more than 60 diseases: cirrhosis of the liver, cancer, and injury by alcohol-related accident or violence. 4% of all deaths worldwide can be attributed to alcohol. This is more than AIDS or tuberculosis. The consequences of alcohol-related problems relates annually to hundreds of billions of dollars. People who are addicted to alcohol no longer benefit from the small pleasures that moderate ingestion can provide.
The transition to addiction occurs when a person is controlled by alcohol. He or she does not use alcohol to function, but stops functioning in order to drink alcohol.
This phenomenon that we consider unique to man could also affect animals, since they too have unlimited access to alcohol. Fruit flies are used to test this theory. These flies are given unlimited quantities of one type of liquid, a sugared water solution that has a 15% alcohol content. After 5 days, the small insects are already in an advanced state of alcohol dependence. The alcoholic flies will do almost anything to access their daily ration of ethanol, including encountering painful electric shocks. During this experiment, the green tube contains sugared water and the red tube contains sugared water that has a 15% alcohol content. The researchers have added a small amount of quinine to the red tube. Under normal circumstances, the fruit fly have an aversion to quinine. Within a few minutes, all of the addict flies have turned red. In another series of observations, researchers in Ulrike Heberlein's laboratory found that alcoholic flies drink increasingly more alcohol over the course of a few days.
They drink twice their body volume of 15% ethanol, which would be the equivalent of what's in wine, in a day. Twice their volume.
This is the equivalent of a 176-pound man drinking 160 liters of wine per day.
We have monitored the levels of internal alcohol of flies that are self-administering, and we were shocked. They were like severely intoxicating concentrations of alcohol.
If alcoholism affects creatures as different as man and insect, then this means that the ethanol molecule affects an area of the nervous system that they both have in common, the area that controls certain instinctive behavior. This observation allows us to understand a crucial component of human alcoholism, the difficulty in halting the addiction process.
The idea that addicts do not want to stop drinking is completely false. They want to, but they can't.
Does this mean that willpower doesn't play a part in stopping drinking?
It is not about willpower. We cannot stop something that is automatic.
Yet more than often, alcoholics are initially judged as weak and as having no willpower.
People such as myself not just think, but know that addiction is a behavioral disease similar to depression or schizophrenia. Society often defines addiction as a vice. What is a vice? What does that mean? That it is your own fault, that you can stop, and if you don't stop, then you don't have any willpower. You are sick, but also weak, so why should other people have to look after you?
For a long time, people thought that alcoholism was a personality disorder or linked to socio-cultural background. In truth, this is only half of the problem. The other half concerns genetic predisposition.
In humans, there are a variety of genes that contribute to alcoholism. The contributions of the genes is about 50% of the risk. The other 50% is the environment and everything else we cannot measure.
Considerable research has been done on animals, and the results demonstrate that genetic predisposition can lead to alcoholism. A well-known study was carried out on the vervet monkeys that live on the island of St. Kitts in the Caribbean. Groups of vervet monkeys became regulars at tourist beaches, where it was very easy to steal liquor with 15 or 20% alcohol content, and they were getting drunk in the space of a few minutes. A study of more than 600 monkeys in the 90s clearly demonstrated that they have varying reactions when given easy access to an unlimited quantity of alcohol. 15% of monkeys are naturally abstinent. They prefer sugary drinks and they avoid alcohol. 65% are occasional drinkers. They only like alcohol at low concentrations and in moderate quantities. 15% are daily heavy drinkers. They become 4 times as aggressive and are less friendly than before. The behavior of the remaining 5% of the monkeys is somewhat intriguing. They consume a large amount of alcohol during short periods of time, several times a day. They fall into a state of alcoholic sedation, or they become aggressive and antisocial. The monkeys that consume alcohol in this way do not survive more than 3 months. The percentages have no link to the different lifestyles of each individual monkey. The only plausible explanation is genetic predisposition. It's interesting to note that the percentages observed when studying monkeys and alcohol are very similar to those that occur when studying alcohol habits in humans. They're genetic cousins.
Having a drink with friends or a good meal does not mean that you are an alcoholic. It means that you are someone who voluntarily consumes alcohol. 10% of the population is addicted to alcohol. They are alcoholics.
It is thanks to studies on animals and their relationship with alcohol that the neurological functioning of alcoholism has been decrypted. It's difficult to imagine that this research could someday lead to treatments that could reduce or cure the problem of alcoholism. And yet,
what you're trying to do is essentially providing a drug that restores the balance to the brain, because the addicted brain is essentially changed in many, many ways.
Our brain has become rigid. It has lost the plasticity that enables it to switch from one behavior to another.
who could have imagined that a study conducted on fruit flies that from a zoological point of view are very different to humans could potentially lead to a treatment for alcoholism? Ulrike Heberlein's team of scientists in San Francisco discovered that male fruit flies that have been sexually rejected by a female tend to drink more alcohol than those that are sexually satisfied. The researchers found that sexual frustration in a fly causes a reduction in the rate of the nerve transmitter neuropeptide F. It controls food regulation, sexual function, and has a calming and sedative effect. The researchers found evidence that demonstrated the part played by this neuropeptide in the males that were attracted to alcohol when they were not sexually satisfied. An equivalent regulatory nerve transmitter, neuropeptide Y, is present in human brains. The goal is to develop a drug that can control the amount of this neuropeptide and prevent alcohol addiction.
That week, for some reason, I don't know, I used to food.
Alcoholism is a very neglected disease when it comes to development of therapeutics. I feel that if we are successful in providing potential targets for therapy, this could have a huge, huge impact both in medicine and society.
Modern man is the only member of the animal kingdom who is intellectually conscious of himself and therefore of his own death. Alcohol and drugs are used to artificially soothe angst and in the search for liberation from fear, anxiety, and pain. However, the consequences are often dangerous. The alcohol molecule is certainly valuable in the natural kingdom. Man-made technological inventions have meant that the alcohol industry has developed extensively over the past 2 millennia. However, genetic evolution and humanity have not yet caught up.